Now let's talk about quickly the logical design options within Cisco ACI. So far you understood, we talked about a tenant. Within the ACI, you will go ahead and create your tenants. So we went ahead and created multiple tenants. So again, you can have one tenant, multiple tenant. As I said, it's a fully multi-tenant capable. So here we went ahead and created a few tenants out there: IT, Internet, Shared Services, Test Tab, and IPTV. Once the tenants are created, and I just want to recall one more time, and if you recall that tenants are containers, kind of isolates one tenant from the another tenant, and you apply your policies back to your tenant and all, and you can have different policies for different tenants. So tenants can provide traffic and RBAC isolation. So now, just like EPG, two EPGs can communicate, you would need something like a contract and filter. Same thing, because ACI by default is a whitelist, we don't allow any kind of communication. If we want to have a communication between two tenants, we can do that. We call it the inter-tenant communication, and we can do it in multiple ways. Just one of the example, we can import and export certain objects from one tenant. Let's say we can export certain objects from internet tenant, and we can import them into the shared services or vice versa. Now once we have our tenant created, let's look the things that we need to create inside a tenant. And the first thing, you would need to create a private network, which we just talked about. A private network sometimes is called as a context as well as a VRF. You can have one private network or you can have multiple private network. It's up to you. One of the questions that comes pretty often, how do we decide that how many private networks I need to create or we need to create in our ACI solution? So the answer is very simple. You go back and look, let's say you are running a router, maybe let's say Nexus 9000 or some 3800, 3900. Go ahead and have a look and see how many VRF are there. So each VRF, think of each VRF as a one private network. If you have 3 VRFs on your router right now, you will need to go ahead and simply create that many number of VRFs or private networks or contexts within the ACI. So it's as simple as that. So private network, again, I just talked about private network is nothing but your VRF, and I'm sure you're familiar. So the private network is the one, just like our VRF, where we'll go ahead and configure our IP subnet and we'll do any kind of routing and any of the things. Within the ACI, the private network really allows this whole layer 3 separation and overlapping IP range. And if you see here that we have a private network 1, there is a subnet 10.110/24. We have another private network which is using the same subnet range as a private network 1. Because if you recall, within the ACI, we can use the overlapping IP addresses because this subnet really belongs to PN1 VRF. So it will only be visible within the PN1. This same thing belongs to PN2, so it will be visible only PN2. Same thing, we have went ahead and created multiple private networks over here. Now once you have your private network configured or created, the next thing we need to go ahead and create a bridge domain. And if you recall, the bridge domain we talked about is the layer 2 construct, really to isolate or to constrain your broadcast and multicast traffic. And again, you can have one bridge domain or you can have multiple bridge domain. As you can see, the bridge domain is really the boundary, or is the where you will go ahead and constrain or limit your broadcast or multicast traffic. BDs are in short, the bridge domains are in short are referred to as BDs. So the bridge domains are layer 2 construct, really to constrain your broadcast and multicast traffic. Again, within a network, you can have one bridge domain or you can have multiple bridge domain. So as you can see in this diagram here, in this private network, we have 3 bridge domains. Bridge domain by name web, app, and database. And again, I said we can have one bridge domain or multiple bridge domains. So now, anytime when we work with the network, we say, okay, hey, this is the subnet, where is the default gateway? We usually like to put our default gateway on the routers and then have sub-interface or .1q on the switches or something like that. So the similar question comes on the ACI, where should I put my default gateways? So there are two options. You can do one thing. You can have the gateway inside the fabric. So the fabric could act as your default gateway, or you can keep your default gateway outside the fabric also. It's up to you. So let's look, how do we configure or how do we keep the gateway inside the fabric? If you recall that we create bridge domains. On the bridge domain, we can go ahead and configure the default gateway, or we call it a subnet or an SVI. In this example, the fabric acts as the default gateway for host in every bridge domain. So for bridge domain web, any endpoint that will go ahead and assign into the web, for that endpoint, the default gateway is on the bridge domain web. Same thing, any endpoint which belongs to the bridge domain app, their default gateway is on the BD app. Same thing for the BDDB. And again, don't worry, we'll go ahead and do practical. That way it will get much more clear. But I just want you to remember that on the bridge domain, we'll go ahead and create something called as a subnet, and where we can go ahead and configure that, use that as our default gateway for any of the endpoint that belongs to any of the bridge domains. And it's very simple. You go under your bridge domain. There is an option of creating a subnet. So you go ahead and create a subnet. As you can see, we're creating a subnet 192.168.1.1/24. And this is a private subnet. So we are saying that, hey, we are creating a gateway into this subnet, which is 192.168.1.0 because /24, and the default gateway IP address is 1.1, and it's a private subnet. That means this subnet remains within the BD where we are creating this subnet. But the good thing about ACI, once you create a subnet, that subnet is available on all the leaves. So that means you can connect an endpoint that belongs to this BD on the leaf 1 or on the leaf 4 or leaf 5. That SVI is available everywhere. Some of the documentation you will hear or written as pervasive gateway. So something to keep in mind, once you create a subnet or default gateway, it's available on all the leaves. So that means literally you can connect your endpoint to any of the leaf. It's not restricted to leaf 1, 2, it's available on all the leaf. And again, as I said, don't worry, we'll go ahead and do all these things in practical and we'll see all these things in action. So once you have created your bridge domains, you went ahead and created a subnet, which we are calling that our default gateway simply. This just shows the configuration, but I'm going to go ahead and skip on this one, and we'll look at some of these options during the practical hands-on approach. So now we'll go ahead and create our endpoint group. So we went ahead and created an endpoint group by name web, and this endpoint group EPG we connected to our bridge domain web. That means the endpoints which are into the EPG or endpoint group web really can access the bridge domain or the layer 2 construct web. That means any endpoint that we assign in EPG web can use BD web as their default gateway. Same thing for app as well as for DB. So as you can see, in the web EPG, we connected a web server. So that means now the web, we can assign an IP address to web server. For web server, the default gateway is on the bridge domain web. Same thing for the app server, is connected to your endpoint group app, where for the app EPG, the default gateway lies on the bridge domain app. And same goes for your BDDB. And if you recall a few slides earlier, we mentioned that by default, the EPGs can communicate. To allow the communication between the EPG, we would need to create a contract. So that's what it shows. So now this whole construct on the left hand side, you need to talk onto the middle one. You need to create a contract. So when we say they need to talk, we mean that this web server if need to talk to the app server, because the endpoint really needs to communicate. So we need to create a contract. And within that contract, you will go ahead and create something called as your filter, because that really allows. This contract just says, hey, we are creating a permit ACL, but what are we permitting? That is dictated with the help of or by your filters. Same thing, we went ahead and created another contract between the app and the DB, and there will be some filters over here. So far, how do we now, let's say, okay, we have our fabric up and running, everything looks good, But how do we really reach outside world? Let's say you already have an existing network that you want to have a connectivity from the fabric or back to fabric and vice versa. So let's take an example of firewall. Maybe let's say you're running a Cisco ASA or some other firewall and you need to connect that back to your Cisco ACI. So if you see what we have been doing so far, we have been dealing with fabric and all the things within the fabric. Now we are really going outside the fabric. We are connecting something, an external entity back to a fabric. So that's the reason we call it as an external connectivity. So now, because we are connecting the fabric to an external entity, so we create an object or we create a construct, or we call it as a layer 3 because we are going to do a routing here. That's why we're creating a layer 3. And ext out just is nothing but is an external out. So we are saying, hey, and if you see this external out belongs to this private network or to this tenant. So we create L3 outs within your tenant, or we can have a common one also. But for this example, we are creating this layer 3 external out within this tenant. And we are connecting this layer 3 external out back to our firewall. So now, once this connection is established between the fabric and the external firewalls, we can tell our BDs that if they need to go outside, use layer 3, use this L3 ext out to go outside and communicate to the firewall, and vice versa. On this layer 3 external out, we can have a static routing either. So between the fabric and the firewall, we can have static routing, or we can run some dynamic routing protocol like OSPF, BGP, or EIGRP to exchange the routing information between the fabric and the external device. In this case is a firewall. It could be a router, load balancer, or any other device. Now, once this connectivity is established between external firewall and this L3 out, now as I mentioned earlier, now we can tell these BDs or these EPGs, hey, the endpoint, the web server, if you need to talk someone who's on firewall, you can use this L3 to go out. Again, as we mentioned earlier, by default in ACI, we don't allow any communication. So to allow the communication between this EPG web and L3 out, again, we need to go ahead and create a contract here. So here we are creating a contract between web and L3 out so they can communicate. If we want a communication between app and external firewall, we'll go ahead and create a contract between L3 ext out and app. Similarly, if we want our database tier to go outside and talk to firewall, we can go ahead and create a contract. If you don't want your DB tier to go outside and talk to firewall, you can simply drop this contract. That way, we are keeping the DB traffic within the fabric, and it's a kind of an added security. Hopefully that makes sense to you. Now, again on a leaf, we just understood that we can have multiple tenants within an ACI, and within a tenant, we can have our own L3 out to go and talk to the outside world. And again, you can use these as physical interfaces, or you can literally use sub interfaces or VLANs also. So that way, this L3 out maps to your WRF on your router firewall, another sub interface or VLAN we can map to another WRF on the router firewall, and so on. So what we have seen so far that we kept our default gateway inside the fabric. But let's say you already have a gateway set up and you are not in position to migrate that gateway from your external device to the fabric in one go. But there is a requirement where you need to connect your new endpoints to the fabric, but you want to use the existing gateway as the default gateway for the endpoints that you are connecting in the ACI. So that means now our gateway is outside the fabric. So how do the endpoints which we are connecting behind the fabric to reach this particular default gateway? So in this scenario, as it says, we keep our gateways on external device. Let's say we have a firewall, and on the firewall there are existing default gateway for our web, app, and database tier. And we have some endpoints. Okay, before we go and talk about the fabric side, let's see why do we want to do this. So let's say now once you create a contract obviously the EPGs can communicate, but you want to filter some traffic, or there are some kind of policies or filtering which is happening, and you're using your ASA to do any kind of your stateful traffic inspection. In that case, we can send the traffic to the firewall, and we can use the firewall's routing or switching functionality to switch the traffic from one verb to the another, or from one context to the another context, or between one interface to the another interface, and then send the traffic back to the destination. That way we can achieve the stateful inspection, and as well as we can enforce or apply further some more policies according to our environment. So how do we set up this thing with the help of Fabric? So what we do, simple, as it says, simple, we just add firewall interface to EPG. So now once you when you create an endpoint group, within that endpoint group, we'll go ahead and connect a physical interface back from our firewall directly into an EPG. See here, we are not creating a layer 3 out. We are literally we are connecting one of the physical interface to one of the EPGs here, let's say web and DB. So this kind of connectivity is a layer 2 connectivity. Okay, so what we are doing, this connectivity, the type of connectivity that you see where we say we just add a firewall interface to an EPG, we call it as a layer 2 connectivity. Okay, so this is a layer 2 connectivity. And because we are connecting directly to an EPG, you will sometime hear this is a L2 EPG or EPG extension. Sometimes people refer just as simply as a layer 2 extension or EPG extension. Whenever you hear a layer 2 extension or a EPG extension, that means it's a layer 2 connection and you are connecting one of the external device directly into an EPG. So whenever you do this kind of connectivity, now this interface becomes part of that EPG. And by default, all the endpoints within an EPG can communicate. By default, all the endpoints within an EPG can communicate, not between EPG. If they want to communicate between EPG, you would need a contract and filter. So once this interface becomes part of this EPG, and as we understood that by default, all the endpoints within an EPG can communicate, that means any of the server which is connected to this EPG web can communicate to this default gateway. So in this case, we don't need any contract or filter. So that's what it says. So we have an EPG web where we have our physical server connected, which in turn connected to our bridge domain web, which is our layer 2 boundary. And within that EPG, we are just showing the EPG again. Within that EPG, we connected this firewall, and this is called as a layer 2 extension or an EPG extension. Because this is directly connected back to EPG, we don't need any contract or filter to communicate between this gateway and this server. Because by default in an EPG, all the endpoints can communicate. This server was already part of this EPG. Once we did this EPG or L2 extension, this interface became part of the same EPG. Now they can communicate freely. So we replicate the same configuration for our app as well as DB. And again, as I don't worry, we will see all these things action in live when we do hands-on. So just to finish this one, it says no contract needed for host to talk to gateway. The reason I already mentioned you, because this is a layer 2 connectivity, it's an EPG extension, and this approach, this interface becomes part of the EPG, so you don't need any contract. And here we'll go ahead and conclude this first part of the series. I would highly encourage you to really understand all these concepts that we just talked about. And we will be going through some of more concepts as we progress through this journey, and especially hands-on. So once we do some more hands-on, I'll be exposing you some more of practical, but sure, the theoretical portion where we will be very, very limited. I'll not be spending much time like I spent today, like close to 45 minutes or something. But again, I would highly encourage you to watch this series multiple times if you really want to understand some of the things that I will be doing when we do practical, because I may not be explaining some of the things that time. I expect you to know what is an EPG, application profile, what is a contract, why are we creating a contract, why are we creating a filter, why are we creating a VRF or a subnet, why we connecting a firewall interface into an EPG, what is a layer 2 extension or an EPG extension, or in fact a layer 3. But as I said, I will be showing you more hands-on approach. So stay tuned. In the next part, I'm planned to show you the physical topology that we will be working with. And in the next series, we'll go ahead and bring up our fabric. So where I'll go ahead and show you how do you really build your fabric from the scratch, the day one, when you buy the new ones, once you have the physical connection. And I will walk you through the physical connection that I did. And once that is done, from there to take and bring it to the GUI where you can start configuring your policies. So thank you so much again for your interest. And again, I would love to see your comments. If you have any kind of comments, positive, negative, do leave me your feedback. That way I know what my subscribers are looking, how can I improve and provide some more relevant or useful content, or any other topic that you feel is interested to you and to the broader community. I can certainly work on that one. So with that, I thank you for your time. Thank you so much.